Okay, so we continue the lecture in this video. So I was talking about evolutionary models. Now, the first model in the evolutionary class is called prototyping. So in prototyping, what we do is we look for the basic user need. What is the most basic thing that the user will need in using this software? So we make a quick plan for it. We model and we design, make a quick design. We design a prototype, then we deploy. But after we deploy, we try to get feedback from the users of this software. And now, based on the feedback they give to us, we try to then improve on our software by going through the phase of communication, planning, like that, till we are done with the software development. Another type is known as the spiral. Now, please note, before I go to spiral, let me recap the incremental method. In incremental method, I said we have a set of objectives and we then go through each one of them then till we then get our software. Okay, so, and again, I said that in the evolutionary model, we start with a prototype of the software and we keep expanding on it till we get the final software that we need. However, in evolutionary model, we get a small part of it. We require for a small part of the project. And that's evolutionary spiral. Then we go through the planning, modeling, construction, deployment. And again, after we're done with that, we then ask for some more. Then we do that again, then ask for some other ones, then we then continue like that till we end the project. Please note the difference between this method and the incremental and prototyping. In incremental, we've already done our initial requirements gathering. We then go through the phases. In prototyping, we start from a small software that we then keep elaborating on. In evolutionary model, we're not going to ask for the entire thing. We first start with the planning of a part of it. We model, we construct. Afterwards, then we go on like that. Now, other ones include component-based development. This works in situations where reuse will be important. So, for example, if you look at current API technology now, where you want to create APIs, where you now want your laptop or your computer or your web to then create get responses by making API requests. Now, in that kind of situation, it is not only one system that is making that request. So it's a component. So that is called the kind of method we use for that is called component-based development. So it's a component. Now that component can be your API, application programming interface that your devices will make requests on. So that's a component. So you can look at it that way. Formal methods. Now we all use Google so much. Now formal methods emphasizes mathematical specifications of requirements. Now you want to talk about the mathematics behind your method. We all use Google so much, but what if I tell you that the Google PageRank algorithm that is developed by PageRank, that developed by Larry Page, who is one of the owners of Google. Google is owned by O'Brien, but for his first name O'Brien and Larry Page. Now, Larry Page's algorithm, called the PageRank algorithm, is purely mathematical in nature. So, if you think you have a method that is purely mathematical, then you want to go through from a method. Then we also have something called the aspect-oriented software development. Now, this emphasizes aspects, where we divide our software into various aspects, then we then develop based on those aspects. Then we have something called the new method that is running in the world now, known as the unified process. And it's a use case driven, architecture centric, iterative, and incremental software process, closely aligned with unified modeling language. Now, what UP defines is that as we're communicating, trying to start the project, and as we're planning, that is what's called inception. As we're planning and we're modeling, that is called elaboration. Construction is construction. But as we're constructing and we're looking at deployment, that's transition. Transition from the laboratory to production. And of course, we then have our production right here. Now, two things you need to note. This inception, which is a combination of communication and planning, is now a whole field in ICT known as ACOPS. You can Google it up. And again, construction and deployment is another field that is upcoming and is already gaining ground. It is called DevOps. As a matter of fact, I ran into one of your, no, not really run into, we were discussing, we've always been in contact. This guy graduated from, he's your senior, graduated like 3-4 years ago, graduated from a Boeing. He's into DevOps now in Lagos. And I've spoken to him and he's magnanimous enough to teach you guys what DevOps is all about. So in one of our lectures, I'll be bringing him to speak to you guys about DevOps. So DevOps is about how to manage our releases, how to add the smallest changes to our development, to our software, so as we can easily transition from develop construction down to deployment. And this is elaborated in this diagram, where if you look at it, this is like our basic phases, workflows, our basic phases in software development. Now, these are the UP phases that I mentioned just now: inception, elaboration, construction, transition, and production. Now, at the moment that we are making requirements, you can see that it is between inception and elaboration, and it peaks just immediately after inception. You can look at the bars. This is what I mean by peak, is where the bar is highest. Now, when we're analyzing, the process of analysis starts from inception, going ahead as construction, when we're still analyzing, no matter what, even when you are developing, you are still analyzing what you are developing, and it peaks at elaboration. Same thing with design. You can see that design also starts somewhere almost at, when we are done with elaboration, we are so sure what we're doing, inception I mean, it peaks at elaboration, when we've basically elaborated our software, we've designed. Then down to construction, we are still designing till we want to move into transition. You keep designing, and designing, make updates on your design. Implementation, of course, the moment you start elaborating, you start thinking of how to implement. And you can see that, of course, implementation is at the peak during construction. That's what we are really coding. Then it goes now during transition. Of course, once you are about transitioning, you don't do much coding, just debugging, adding small things to your project. Then finally, testing. Now, of course, testing will peak just before you end. Of course, by the time you start elaboration, construction, you can say you keep testing. Now, of course, when you are done with construction, of course, at that time you are testing so much. But at the moment you are transitioning, you still have to be testing and keep testing till you get to production. Now, of course, support will peak while you are in production, and of course, support will never go down. That's why you can see that it didn't go down. You keep supporting your software. Now, to make this clear, UP products, work products, what are the things, so you make it clear to you at inception, what are the products, what are the things to expect, what are the things that is expected that you have, the documentation, the end goals of each of the UP phases. Now, at inception, we should have a vision document, we should have an initial use case model, a project glossary, business case, initial risk assessment. Don't forget, is it between communication and planning, business model, and the likes. At elaboration, like I said, is between planning and modeling. After you finish planning, you're modeling. So what I think you expect to have, you should have a use case model, design, requirements, analysis model, software architecture, executable architecture prototypes, and things like that. At construction, of course, that's when you're building your software. Design model, software components, integrated software increments, test plan. How do you want to test cases, support documentation? That's what you think you should think of when you're constructing. And transitioning, like AppOps, DevOps, like I said, deliver software increments, like I said, manage releases. Making DevOps has to do with managing in your increments on your software, from easy coding to easy deployment, to maybe to manage your releases in short amount of time. So deliver software increments. If you can see, one thing is exactly that thing that you added to your software, the new things that it's going to do, you must be able to document that. Best test reports, general user feedback, because don't forget, it's from this feedback that you're going to use. This feedback is what you're going to use again to improve your software. So there's a bit of discussion here. Okay, this shouldn't be. Let me just title this discussion, please. Now, descriptive process models advocate an orderly approach to software engineering. That leads to a few questions. If prescriptive model process strives for structure and order, are they inappropriate for a software world that thrives on change? Of course, like I told you, that there's a software explosion right now because of advent of mobile phones and the likes. Yet, if you reject traditional process models and the order they imply, and replace them with something less structured, do we make it impossible to achieve coordination and coherence in software work? The idea is, okay, now since we are claiming that the old waterfall model and the likes are outdated and are not appropriate for the kind of software that we have right now, where people ever just want to have their software go to the market, if possible, within a month. Now, and again, but then since then they are kind of structured. If we now reject this structure that they bring, how do we then go about our process of software development? It's what you should think about. I won't give you the answer yet, but we will revisit this later on. Thank you for the lecture, for being in class. Then we'll continue again next week.